Let's take a look at 2.5, lesson 2.5 here. What I'll do first is open it up on Power School Learning. So I go to Power School Learning, click that link. And once this loads, I'll choose the pre-cal out of your classes. Make sure you choose pre-calculus. From here, I'm going down to chapter 2 because it's 2.5. I'm going to chapter 2. That's what that means. Down to lesson 5. You'll notice at 2.5, there's only one more lesson in chapter 2, and we will have completed chapter 2. If my memory is right, we go through 10 chapters in pre-cal. We go through 10, and this will be chapter 2 down. Actually, no, take that back. I think we only go through 9. So this will be 2 down on our path of trying to knock out all 9 chapters that we're going to go through. So if you're listening to me, you're here, you've accomplished number 1, the 4 tasks. Hopefully you signed your attendance up at the front of the room. I did not check that, but hopefully you signed in up at the front of the room. Number 3, in class work, go ahead and click that link. This is where we will submit our packets. Once that opens up, we can start this exam. And I'd also encourage you, if you're on a Chromebook, just to use 2 fingers, double click Desmos so that you have that open. If you don't have a Chromebook, if it's a different type of device, just right click and say open a new tab. If it's a cell phone, hold your finger down on it until it asks you to open a new tab. Either way, have that open. All right, with that, let's start with number 1. I'm going to ask a few different questions here, more than what's written on it. If my stuff will wake up, here we go. On number 1, first question I'm going to ask is, what's going to be the total number of zeros? The total number of zeros for this problem? 4. So you take your leading term and you ask what's the power, which we're going to learn is called a degree. So the highest power is called a degree. The degree is 4. That means there's 4 total zeros. Remind me of this. The first breakdown of zeros. What are the first 2 types of zeros? Ones you can see, one you can't see. What are the names for those? Real or imaginary. So there's real and imaginary. Within the real, there's 2 different types. You could define within the real. They could be, some of the students said a moment ago, it could be rational or irrational. And as a reminder, irrational means it's a decimal that's never ending, it does not repeat. A rational is anything you could write as a fraction, which by rule, that means if it's a decimal that repeats, if it's a decimal that never ends, it's because it repeats, but it very likely does not go on forever. Some like a 1/3 would go on, but it repeats 0.33333, so on. So anyways, there's 4 total zeros, and I'm going to go over here and graph this first. And before I even list off the possible, I just want to review this. Let's look at this picture, and then we'll actually do what the problem asks us to do. I want to kind of walk through how many here are real, and so we can write down how many are real and how many are imaginary. So here's the picture. Let me zoom out a little bit, make sure I'm not missing anything. Okay, here's my picture. All right, how many zeros on this graph are real? This has 2 real zeros. So if there's 4 total, 2 of which are real, how many does that leave to be imaginary? 2 would be imaginary. 2 are imaginary. And then among the real, when I click this, how many of these are rational? How many of these zeros are rational? Both. Both are rational. What is this as a fraction? -1/2. And this is just obviously 3. So of the 2 real, they are both rational. Both rational. Okay, now let's answer what the problem wants us to do. I'm going to just say x equals -1/2 and 3. Okay, now let's do what the problem asks us to do. If you're going to find all the possible rational places this graph could hit, it matters nothing what's on the inside. It all comes down to the leading terms coefficient and the least terms coefficient. What is the coefficient for the first term or the leading term? 2. So we're going to use the coefficient 2, and we're also going to use the coefficient here. Ignore the negatives. For the least term, what's its coefficient? 15. And if you remember, the rule is, I'm gonna go ahead and clear this off. It is the plus or minus the factors of the least coefficient divided by factors of the first. I think last class I just wrote factors of the least and factors of the first. Factors of the leading coefficient. Or I might have just said last and first to be shorter. But that ultimately is what we're doing. So on this problem, what are, if our leading coefficient is 15, I'm sorry, our least is a 15. What are the factors of 15? There's 1 and 15. 1 times 15 is 15, and 3 and 5. So I'll put them in order. 1, 3, 5, and 15. What are the factors of 2? Just 1 times 2. And again, the plus and minus takes care of the case of if you're like, well, what about positive 1 times negative 15 or negative 1 times positive 15? Well, that's what the plus or minus does. It takes care of it. And so all we would do is distribute this, or I say distribute, I'm sorry, divide all these out individually. So you'd have 1 divided by 1, 3 divided by 1, 5 divided by 1, 15 divided by 1. So going off of that, you'd have 1, 3, 5, and 15. 1, 3, 5, 15. B is out. 1, 3, 5, 15. 1, 3, 5, 15. Okay, then you would need to divide everything by 2. So 1 half, 3 halves, 5 halves, 15 halves. That eliminates A. A does not have the rest of the list. Does this have it? 1 half, 3 halves, 5 halves, 15 halves. That looks pretty good. So what about on D? Oh, they added a 2. Do we need a 2 up there? No, that one's out. So the correct answer would be C. Now that I've done one, I'm going to let you do DOL number 2. I'll let you write out all the possible rational zeros for number 2. As a reminder, the shortcut I gave you to kind of remember this is I said it's plus or minus, and I used a saying that's kind of popular among Christian church circles, I guess you'd call it, is that the last shall be first and the first shall be last. Just kind of a way to remember it's the factors of the last divided by the factors of the first term. That's another way of that I described it last class. And now number 3, it says write a polynomial function of least degree. That means least degree means the fewest number of powers possible. With real coefficients, I crossed out in standard form, meaning we can write this in factor form that has 2, -5, and 3 plus I is 0. So the first thing I want to remind you of, when you deal with zeros, so we have the zeros x equals 2, x equals -5, and then it says 3 plus I. The thing about imaginaries is we learned last class, imaginaries always come with a pair. It's technically called a conjugate pair. It just means if you have a positive I, you will also have a negative I. So they'll always come as a plus or minus. If you're wondering why is that, that's because the I comes from when we have a negative square root. And anytime you add a square root to something that's not originally there, it comes with a plus or minus. So it'll always have a plus or minus of the I. So the way I did this last class is I described that zeros come from factors. And so if you wrote this out, I'll just call this f of x. My board is going really slow this morning. Sorry, there we go. F of x, what factor would create the 0 of x equals 2? What would be the factor if you put everything on the side with x? It would be x minus 2. So there's the first factor that provides the 0 of 2. What factor would provide the 0 of -5? If you add the 5 across, you would have x plus 5. So as I put them in, the parenthesis is the lie. Up here, this is the truth. The parenthesis is the lie. Whenever it's on the inside, it's a lie. So you're adding 5 over. And then over here, what happens with that positive 3? It's going to become a -3. Let's do the positive I first. What happens to the positive I? Comes a negative I. Okay, and then that is technically 2 zeros right there. So you'd have another, that would be x minus 3. Again, you'd subtract the 3, And then for the negative I, what happens to get it across the equal sign? You'd have to add it. And so if you multiplied all this out, you'd have your answer. This right there is what we call factored form, because they're all written as factors. The beautiful thing about factored form is it tells you your zeros. The nice thing about standard form is it tells you your leading term and it tells you your y-intercept. But we're going to get into that today. Lesson 2.5. So lesson 2.5, we're going to deal with what we call reciprocal or rational functions. Okay, specifically, I call them rational. Rational, remember, like I told you, it means a fraction. It's specifically when you have x in the denominator. So let me get over here to these rules. I gave you this rule sheet. Okay, so we have a new cheat sheet for this that I'm going to refer back to all day again. You can title this, I would recommend you title this cheat sheet. So have this open so you can refer back to this frequently. Okay, so I have my cheat sheet on the right side of my screen so I can see it on each problem as we go forward. I left it right here, and I might try to see if I can get it where I can see the whole thing even with that open. Well, I can get close. So here's what we're going to do. We're going to first take out, I know these problems are going to walk you through first the asymptotes rules. I'm going to walk through on every problem all these 5 things, because this is kind of like a perfect overview of everything. Almost everything we've done this year, not literally everything, but almost everything we've done this year. So I'm going to do all 5 of these little topics as we go through the lesson today. So the first thing I'm going to do, according to this, is find my domain. Okay, so what rules have you learned about domain? I've told you at the start, we assume a domain is all reals unless you see one of 2 things. What were the 2 things? Division and square roots. So what are you not allowed to divide by? 0. Okay, so the first thing I'm going to do here is find my domain. And so for the first time, I'll write domain. After this, I'm just going to do D:. So domain. What you do is you take your denominator and you say the denominator cannot equal 0. X minus 1 cannot equal 0. And we solve this. To save space, I'm just going to write the answer just to the side. What would you need to do algebraically to solve to get X isolated? We would need to add 1. Now I told you I'm going to write that to the side. So what I'm going to do first is show the math. You see how we'd have X does not equal now positive 1. What I'm going to do now is I'm going to, if it'll allow me, I'm going to move this right here and I'm going to erase the top. So that's my domain. What that means, by the way, is the domain will be all reals except for 1. This graph will hit every single X value except for 1. You could also write this from -infinity to 1 union 1 to infinity is another way of looking at that. That's our domain. So I'm going to first do that. Secondly, I'm going to come over here and find any holes or vertical asymptote. So what this says, it occurs at any X values, a hole that is. A hole, if you're reading your cheat sheet, occurs at any X values when the factor of X is eliminated. So if you can eliminate something. Now here's a reminder. You cannot cancel terms. So I know that's an X and an X. You cannot cancel those because that would be canceling terms. You'd have to be able to cancel it as a factor. Like this factor would have to match this factor, which they don't match. So nothing cancels. So for step 2, I do not have any holes. A vertical asymptote will occur at any spot where you had a break in the domain. A hole or an asymptote will fill in the whole domain. So these 2 are really opposites of one another. So step 2, I'm going to do also in blue because it's the opposite of the domain. It'll only be the values that were listed in the domain. In this particular case, this is going to create a vertical asymptote because it did not cancel. So we have a vertical asymptote. Now check it out. These are solved the same way, but they're exactly the opposite. So instead of saying X does not equal 1, I'm going to say X equals 1. My asymptote is X equals 1. They're exactly the opposite. So I'm doing them in blue because I'm doing it from the same math work. You'll be able to do this from the same math work each time. So that's the second thing we're going to do. The third thing we're going to do is find the horizontal asymptote. Now there's 3 rules that'll define the horizontal asymptote. It all has to do with the exponents. So what I'm going to do here is list the exponents of X. this does not show a power on this x. So what power would it have if it doesn't show one? A power of 1. What power is down underneath? 1. Okay, so the three rules are relating the two powers. If the exponents on top are bigger, that is where, if you look on this, exponents, these are what these stands for. Exponents are the same. The exponent is bigger on bottom or bigger on top. If it was bigger on top, there would not be a horizontal asymptote, but you'd have this thing called an oblique asymptote or slant asymptote. That's not the case. You see how my exponents are the same? I'm going to go to the rule that looks like eats DC. You'll probably hear me joke around, say, eat some dang chips, or whatever. You can come up with whatever you want. Exponents are the same, divide coefficients. That's what it stands for. Exponents are the same, divide coefficients. So what you're going to do to find your asymptote is it's going to say here, exponents are the same, y equals divide your coefficients. So on step 3, since this is new math, I'm going to change colors here. I'll do it in red. Step 3, my horizontal asymptote. You figure out the rule, which in this case, the rule is eats DC. So the rule is eats DC. Which means the coefficient will be y equals, and you divide your coefficients. I have a coefficient of 1 here and a coefficient of 1 there. What's 1 divided by 1? Which is just equal to 1. I'm going to erase that and put 1. That is my horizontal asymptote we're about to see. How that relates, the horizontal asymptote is telling you you're in behavior. As it goes left and right, it'll go to the value of 1. This graph will go flat to the value 1. Okay, we have 2 things left. The y-intercept occurs when 0 is substituted for all x values. This is new math. I'm going to change the color. The y-intercept will occur whenever we substitute 0 in for all values. So it'll happen at when we have 0 divided by 0 minus 1. What is 0 divided by anything? 0. This y-intercept will occur at 0. So it's just a 0 there over -1, so it's 0. And finally, the x-intercepts occurs when solving the numerator equal to 0. Let me go black. X-intercepts. And then that's where we're going to stop here. The x-intercepts are found by solving the numerator equal to 0. So you would just have it at x equals 0. I guess I could have put y equals on this one. Let me get the color right. Green. Y equals 0. So this is going to hit the origin. Since the y-intercept is 0 and the x-intercept is 0, it's going to be 0, 0. This graph will hit the origin. So now we'll look at the picture, and I'll walk you through it. What is the one value on this picture that the graph does not touch? 1. That's the vertical asymptote. So where the domain does not exist, it's got to be, we refer to the space where the graph does not exist by something. And this one, we call it a vertical asymptote. That is the vertical asymptote. Here, I did that in blue. Let's say vertical asymptote at x equals 1. That's what that is right there. What do you call this red dotted line? That was the horizontal asymptote. This would be our horizontal asymptote, which was listed as y equals 1. It would also serve as the break in the range. Okay, the x and y intercepts, we said we're at 0, 0. Does this graph hit the origin? Yes, it does. I'll put the point in purple. Even though one was purple, one was black. That hit the origin at 0, 0. And so there's a lot of information we just did. We could obviously graph this, but that's how you do the algebra. And the algebra is a good little practice for everything. A lot of the things we found this school year. So there it is. Let's reload and do the whole problem all over again. So part B. This time I got a more complex equation. And we're going to find all 5 things. So who remembers off the top of their head what the first thing was that we found? Domain. I'm just going to do D colon. The domain, what are you not allowed to do in math with a division? Divide by 0. So what you would do is you would solve that 2x squared plus 1 cannot equal 0. All right, what would be the first piece of math that we would need to subtract 1? So we would subtract 1, and I'm going to write that off to the side. So we'd have 2x squared cannot equal -1. I'll erase this now. What's the second step? If you're trying to isolate the x squared, you would divide by 2. That would be the second step. And so now we have x squared cannot equal -1/2. I guess I have enough space. I could leave the -1 on there so you can see how we got there. Okay, and finally, how do you get rid of a square? Square root. Who remembers whenever you add a square root that's not originally there, what comes with it? Okay, so we learned last class that that is called an I. If you have a negative inside a square root, that's imaginary. It's not real. You can't do that. So that means we'd have x cannot equal plus or minus I square root of 1/2. So I took out the negative and replaced it with an I. So that comes out and becomes an I. The negative does. And that's imaginary. So you know what that means? If the domain cannot equal an imaginary, if the domain can hit all reals. This domain will be all reals, since the only value it cannot touch is imaginary. I'll go ahead and give you a sneak peek. You see how this graph hits all reals? Yeah. Yep, all reals. So secondly, if the domain is all reals, there are no holes or asymptote. No holes or vertical asymptote, I should say. No holes or vertical asymptotes. And that's because the domain was all reals. Holes and vertical asymptotes are exactly the opposite of the domain. So if the domain's all reals, hitting every value, then there's the holes and vertical asymptotes will hit no values. It won't exist. Okay, so I'll do those in the same color each time. Third, the exponents. Take a look at your exponents here. Are the exponents bigger on top, bigger on bottom, or are they the same? Okay, so for the horizontal asymptote here, the rule we follow is exponents are the same. Do you remember what DC stands for?
Divide coefficient.
We're going to divide our coefficients. So the coefficients in front of the squareds would be 4 divided by 2. What is 4 divided by 2? 2. And that's why you have this horizontal asymptote. You have a horizontal asymptote at y equals 2. That's why you have that. Again, that would refer to if you're finding your end behavior or your limits, that's how you would know what number it's getting flat on. This is not, as you go right forever, it's not rising, it's not falling, it's not stopping, it's getting really, really flat, and it's getting flat on the number 2. The y value can actually, so the asymptote, again, let me go back. So Sergio asked a great question. Wouldn't it be y cannot? For the asymptotes, you don't say cannot equal, that's domain. The domain, you talk about what it cannot equal. Just the same, if you were actually finding the range, you might say the range does not equal 2. It approaches it, but the range doesn't get to 2. That might be true. But this won't be exactly the opposite of range, because if you can see, a range doesn't hit all the negative values, nor does it hit anything above 3. The range only exists between, let me go ahead and write that in there. This is a good little note. This is not exactly opposite of the range. They don't follow the same rules as number 1 and number 2 do. They're not exactly opposite, because the range here, if you were to find your range, the lowest it approaches is 2. It doesn't quite get there, so I'll put a parenthesis. The highest value is 3, but that's a bracket. It only exists between those values there. So the range is not always the opposite of the horizontal asymptote. It was on number 1. If I would have found the range here, I would have said the range is y does not equal 1, but it does hit everything else, all reals but it. But it's not always the opposite of a horizontal asymptote. Running out of space there. Okay, with that, I'm going to move on. The last 2 things, asymptote, the intercepts. I'll do these in the same color. The X-intercepts. No, I found Y-intercepts first. I'm sorry. Y-intercepts. They occur when 0 is substituted in. So if you substitute a 0 for each x value, for the X-intercept, no, Y-intercept, I'm sorry, the Y-intercept. you would substitute 0 in. So you'd have 4 times 0 squared plus 3 divided by 2 times 0 squared plus 1. What is 4 times 0 squared? Yeah, that's 0. What is 2 times 0 squared? That's 0. So it's just 3 divided by 1. 3 divided by 1 is 3. So this should hit the y-intercept up at a height of 3. As you can see, it does there, 0, 3. And the x-intercept you can find by solving the numerator equal to 0. So it's kind of like the domain rule, except for you're doing the numerator. So you would say 4x squared plus 3 equals 0. And you would solve this for the x-intercept. What would be our first step here? Minus 3. And what we're going to find out is it's imaginary. That's why it doesn't have an x-intercept. And we'll have 4x squared equals negative 3. Well, then we divide by 4. Divide by 4. So x squared would equal negative 3/4. And finally, how do you get rid of a square? Square root. And whenever you add a square root that's not originally there, it needs to be a plus or minus. So this will have a plus or minus. And so we'd have x equals plus or minus. Are you allowed to have a negative square root? Starting here or starting from now on? What are you going to do if you have a negative square root? It's going to become an I. So this will be I square root of 3/4. Or if you wanted to reduce it, you could say square root of 3 divided by 2. You could also write it that way. I took the square root of the denominator. I know the square root of 4 is 2. So I simplified that and I just left the square root on 3. You can write it that way as well. So, oh, that's imaginary. I shouldn't have circled that. If it's imaginary, does it have an actual real x-intercept? So you'd have no x-intercept. No real, let me put it that way. No real x-intercept. If someday in the future, so this is the beautiful thing about the world we live in. We don't know everything that it ever is or is to come. If someone comes up with how imaginaries play in on x-intercept, maybe you'll be ready to go and use it. But for now, we'll say there's no real x-intercept. So that is a lot of information. I walked through what we're going to do all day today is just find those things. It's good algebra, it's good practice, and it'll teach us some things. On your DOL, you're not going to have to find everything. And I am ahead of the game. Whoops, my bad. I got another problem to do. Let's start on this one. I'll leave room for a graph here in a second. What's the first thing we've been finding? Domain. So the domain, all right. What is the domain of this portion right here? This is all reals. Good. That domain is all reals. So that's not going to be thrown off. This is the part that might throw off my domain. What are you not allowed to divide by? 0. So we would say that 2x squared plus 1 cannot equal 0. Is that the same equation we just had?
Yeah.
Okay, so what do we know about that domain?
It's all real.
That's going to be that same imaginary. So the domain is going to be all reals. And I'll just say here, see example 1b. So that was done on example 1b. We did that domain. Okay, step 2. If the domain is all reals, what can you tell me about any holes or vertical asymptotes in this graph? Will there be any? No holes or vertical asymptotes. Since the domain is all reals. All right, so I moved on to horizontal asymptotes. Now, horizontal asymptotes. When you're only dealing with a fraction, would follow these rules. But ultimately, you need to ask yourself, what's in a fraction? I'm going to get ahead for a second, and then I'm going to back up to this problem. The way an asymptote actually works, those shortcut rules, what's actually happening is if you did a long division, the horizontal asymptote is the answer to the math. Okay, so if I did a long division here, that's the answer to the math. It would ultimately be 2. If you're doing a long division, that would be your quotient. It would be 2. So that's really what we're doing. When I come to this problem, I could try to do the math here, and I would get 0. It's bigger on bottom. You follow what I'm saying? This part of the fraction, it's bigger on bottom. But I have a different rule to bring in here. I have 2 portions of graph. Remember on lesson 2.1, I told you that we could graph power functions with one term. And on lesson 2.2, I told you the shape of the graph will be determined by the greatest power. I have a question for you. Which power is bigger? This power of 2, or over here, after you simplify, it's a power of -2 because it's down the bottom. Which power is greater? +2 or -2? 2. This is going to determine the shape. So this will determine our shape. And so our horizontal asymptote is actually going to be this oblique asymptote. This will have an oblique asymptote. Oblique asymptote. And that's because after you simplify the fraction, this 4x squared is greater than a -2 power. Oblique asymptote. And the oblique asymptote will be the leading term, which is y equals 4x squared. I will show you this in a moment. This graph, as we zoom out, will just approach 4x squared because that's the greatest positive power. That's, since it's multiple terms, you go off the greatest power. That's lesson 2.2. I want to put that in parentheses. See lesson 2.2. See lesson 2.2. That when you have a polynomial, you go off the greatest possible power, and which is this one. And so that's our oblique asymptote. All right, I'm going to skip down and now finally do the last 2 things. The 4th thing, the Y-intercept. How do you find a Y-intercept? Place x with 0 all the way across the equation. So it'll be 4 times 0 squared. Should say y equals 4 times 0 squared plus 3 over 2 times 0 squared plus 1. I go to simplify. What is 4 times 0 squared?
0.
2 times 0 squared?
0.
0. So I have 0 plus 3 over 1, which is equal to 3. It's going to hit the y-intercept at 0, 3. And then finally, the 5th thing, the x-intercept. How do you find an x-intercept? You set the numerator equal to 0. And so you might be going, okay, I don't know what to do here when there's 2 things. Well, set it like this. And basically, it's going to be, can 3 ever equal 0? No, that's impossible. But can this part equal 0? Yes. To find your x-intercept, you're going to say it's going to be x equals 4x squared equaling to, 0 equals 4x squared. Let me say this again. 4x squared equals 0. There we go. And you would solve that. Actually, I'm going to check this one. I'm not 100% sure. Before I go too far on that, let's graph this. I'm doubting myself all of a sudden. Let's graph this equation and see what we come up with. So I have 4x squared plus 3 divided by 2x squared plus 1. This actually has no x-intercept. Okay, so that is not true what I was trying to say. When you solve the numerator, you would have to get a common denominator there. And so I'm just going to say none for the sake of time here. So we don't have to get it. You'd have to get a common denominator. That's what you'd have to do here. None. So now let's graph the picture and see if all of our math was correct. I'm going to zoom in just a tad bit here. Let me change this to a -10 and this to a 10 so we can see it a little bit better. Here's our picture. Oh, come on. Here's our picture. All right, check it out. Was the domain all reals? Did it have any holes or vertical asymptote? No. Oblique asymptote. That means what the graph approaches. If I type in y equals 4x squared, is this what our graph approached? As you go to the left and the right? Is that what the graph approaches? Do these two graphs look very similar? Yes, that's its asymptote. And so now finally, does it hit the y-intercept at 3? Did this red hit the y-intercept at 3? You bet. So we did everything correctly. All right, now it's your turn. I want you to find just the vertical and horizontal asymptote. So just step 2 and step 3. Just step 2 and step 3 is all you have to find for DOL number 1. It might help to find their domain first, do step 1, but all you have to really do is step 2 and step 3. All right, so I was wrong. The domain is on there. So steps 1, 2, and 3 to come up with your solution. All right, with that, I'm going to move on now to example 2. So example 2, it says for this function, and I'm going to start skipping some things here that you can look over later if you want, but I'm going to give you everything you need. It says for k of x equals this equation, and it gives some instructions. We're just going to find those 5 things. If we do those 5 things, we're going to hit everything we need for a day. So what was the first thing I found off my cheat sheet? The domain, which what's the rule with domain when it concerns a fraction? What are you not allowed to do if you're dividing? Divide by 0. So the first thing for domain here is we would take our denominator and say x plus 5 cannot equal 0. And so how would we solve that for x or isolate our x? We would subtract 5. And so we kind of are starting to see the inside lies. That's the inside of a fraction. So the inside will lie. We have x does not equal -5. Okay, so as soon as you have what x cannot equal for domain, and by the way, that means it's going to equal all reals but -5. So in a moment, when I show you the picture, you'll see that this graph will exist from -infinity all the way up to -5, but it'll be a parenthesis. That means it doesn't actually hit -5, and then it'll pick back up and from -5 and go right forever. So there's just going to be one break, and that's at -5. Now, step number 2, since I have a break in my domain, I have either a hole or a vertical asymptote. A hole exists only if you can cancel out the x plus 5. Could I cancel this out? Since I can't cancel the x plus 5, that is a vertical asymptote. So I'll just say vertical asymptote, or VA for vertical asymptote, will exist at x equals -5. That's what's going to replace that break in the graph, is a vertical asymptote, which the textbook usually uses a red dotted line to indicate the vertical asymptote. Third is the horizontal asymptote. So the horizontal asymptote on this time, when I check out my powers, I do not have a power of x in the top. It's kind of like having x to the power of 0. Are my bigger on top, bigger on bottom, or are the exponents the same? Bigger on bottom. So the rule for bigger on bottom, if bigger on bottom, the rule is y equals 0. That's why it says, looks like Bobo. Bigger on bottom, y equals 0. So this one will have a horizontal asymptote, and that horizontal asymptote will be at y equals 0. What that is referring to, I should have written this in the previous problems, is, instead of just saying it, is that the end behavior, as you go left and as you go right on this graph, as you go left and as you go right, the graph will be approaching the value 0. That's what the horizontal asymptote tells you. So if you have a horizontal asymptote, the graph will be getting flat as it goes to the left and to the right. It won't be rising, it won't be falling. It'll get really flat, and it'll be getting flat at the value of 0. That's what that tells you. All right, and finally, the intercepts. How do you find the y-intercept? Replace x with 0. So from our equation, we'd have 7 over 0 plus 5. What's that going to equal? 7 over 5. So at 0, 7 over 5, which is the same thing as 1.4, we'll have a y-intercept. And finally, the x-intercept. How do you find a x-intercept? You would set the numerator equal to 0. Can 7 equal 0? Not possible. So there's no X-intercept. That's doesn't look like a no. Let's try that again. No X-intercept because 7 cannot equal 0. So when I look at the graph, here's my picture. This is the vertical asymptote at x equals -5. Notice the domain does not hit that asymptote. It gets close to it, but it doesn't actually, the graph does not hit it. We have a horizontal asymptote they did not place on there. Let me go ahead and place this horizontal asymptote for us. We have a horizontal asymptote at y equals 0. That's a horizontal asymptote at y equals 0 there. That would break up the range. This range would happen to be all reals except for that 0. And as far as a x-intercept, there is none, but we do have a y-intercept, which we solve for. This y-intercept would be at 0,7/5. One more thing. Notice the powers of x. The powers of x, if you try to simplify just the powers of x, you have a 0 and a negative. That's technically a -1 once the bottom. -1 is odd. That's why this graph is kind of like odd. You see how it's odd here, how it's reflecting across the asymptote origin. That's how the graph will work on rationals, by the way. If the powers, whenever you try to simplify or cancel them out, if you will, a 0 and a -1, that becomes a -1. Since that's odd, it will reflect oddly like that. Okay, let's look at part B. Part B. Finally, we get a little bit of complexity here. Step 1, if I want to find the domain, how would I find my domain? Okay, x squared minus 4 cannot equal 0. What will we do first? We would add 4 to both sides, which means x squared cannot equal +4. Camilla, how do I get rid of a square? What's the opposite of a square? What is the opposite of a square mathematically? Evelyn, you want to help her out? Square root. Okay, we need a square root here. I'm adding a square root that's not originally part of the problem. What comes with a square root that's not originally part of the problem? Plus or minus. This time we do have a square root of 4. It's not imaginary, so we will have 2 breaks in this domain. Plus and minus, what's the square root of 4? 2. So this domain would be all reals except for positive and -2. If you wanted to write that out, it would look like this. And sorry, that's in inequalities. If you want to write it out in interval notation, it would look like this. It would go from -infinity to -2 with a union. Then it would go from -2 to 2, union 2 to infinity. That's how the domain would look in interval notation. So it means all reals except for 2 and -2. So if we have breaks in the domain, what does that mean about step 2? There's either a hole or a vertical asymptote. Will either of these comes from the factors. If you did your factors, this comes from the factors x -2 and x +2 when you add it over. Could either one of those cancel with x +1? Do they cancel? These come from the factors. What I'm saying is this comes from the factors. If you subtract it over, x -2 and x +2, that's the factored form. Let me just write it out. Here's the factored form. We have x +1. If I add the zeros across as factors, it would be x -2 and x +2. Can I cancel either of those out? No. If they don't cancel, they are vertical asymptotes. Since they don't cancel, they are vertical asymptotes. We have vertical asymptotes at x equals positive and -2. Remember, these answers are exactly opposite. That means it's a break in the domain. This is telling you what fills that space. It's a vertical asymptote. Step 3. Oops, let me go to red. Step 3. My horizontal asymptote. Check out your powers. Are my powers bigger on top, bigger on bottom, or are the exponents the same? Bigger on bottom. The rule for bigger on bottom looks like Bobo. So if it's bigger on bottom, y equals 0. So the horizontal asymptote here, horizontal asymptote is y equals 0 because we were bigger on bottom. Finally, the intercepts. Step 4, the y-intercept. How do you find a y-intercept? You put 0 for all x's. So it's 0 plus 1 over 0 squared minus 4. I cancel these out. It looks like it's going to be y equals 1 over negative 4. Or you could write it this way, 0 comma negative 1/4. That's going to be a y-intercept. And finally, we finally make it to a x-intercept. How do I find an x-intercept? Numerator equal to 0. So how would I solve that? We would subtract 1. And so we find out that this would be at x equals -1, or you could say -1 comma 0. Let's check out the picture. If you simplified your powers, if you try to cancel 1 and 1, you'll see it's a -1. That's why ultimately the outsides are odd. Because the powers, if you simplify, you have 1 power left over. And so that's odd. That's why it goes this way on the outsides. The insides, because there was 2 breaks, there's a part in the middle, and that's how it turns out looking. Notice we have a y-intercept right here. That y-intercept would occur at -1/4. We have an x-intercept at -1. The limits, as he goes right, it would flatten out at 0. As it goes left, it would flatten out at 0. So the end behavior would go to that. And here are our vertical asymptotes. Let me write both of these vertical asymptotes. We have x equals -2 and x equals 2. There's a lot of visiting. Make sure you're on track with me, please. And we have this horizontal asymptote. Again, y equals 0. So there's all the information we found. The domain, the only breaks were at -2 and +2. I think that's enough for you to go through these steps again. This one is the one that's only steps 2 and 3. You only have to find vertical and horizontal asymptotes for this problem. DOL number 2. On this problem, you will have to X factor the denominator. If you want to get your values, you'll have to X factor the denominator. All right, example 3 here. Again, it's going to tell us specifically what to look for. We're going to just find all 5 things. So number 1, the first thing I've been finding is domain. So my domain, what am I not allowed to do with a division? Divide by 0. So 2x squared minus 8 cannot equal 0. What's the first step there? Add 8. We would add 8 to both sides, which means 2x squared could not equal +8. Now what? Not square yet. We need to first divide by 2. So x squared cannot equal 4. And then finally, last step, square root. What, when you add a square root that's not originally there, what comes with it? Plus or minus. So we'd have x cannot equal positive or negative 2. That's our domain. What does it mean? What does it mean if you have a domain break? There's either a hole or an asymptote, a vertical asymptote. Very good. Okay, so how do we find that out? You go off the factored form. So here up in the numerator, I have a trinomial. I'll show you how the bottom factors based off of our answer here. I'll do that first. Was there a GCF? What was the GCF? 2. So I'm going to first put the 2 out front because that did have a GCF. After that, you can get your answers from the zeros. But if you have a GCF, you need to put the GCF out front. This did. It had GCF at 2. The zeros will provide your factors. So the positive 2 would come from the factor x minus 2. And x minus 2 would come from the factor x plus 2. So that's how the denominator factors. And we got that from our answer. Just kind of working backwards. If it has a GCF, you need to include that. But other than that, your zeros provide the factors. The numerator, you would need to ask yourself, this is A, B, and C. What are factors of negative 12 that add up to be negative 1? Factors of negative 12 that add to be negative 1? Negative 4 and positive 3. Since that A squared, when we split this A squared, the A term, the power of the A term, I should say, since it's just a 1x squared, it just becomes 1x minus 4 and 1x plus 3. That's the factored form for the numerator. Okay, question for you now. Now that I've factored this problem, that right there is f of x. I could have put that at the front. F of x equals, that is what it is. Do any of these factors cancel out with one another? So I did a lot of work just to find out. If nothing cancels, it's a vertical asymptote. If it were a whole, one of those factors would have matched. So the vertical asymptote is x equals positive and negative 2. And granted, we could have looked at the graph to find this, but I want to practice the algebra today. Step 3, look at your powers. Are the exponents bigger on top, bigger on bottom, or are they the same? The leading term for both the numerator and the denominator. Exponents are the same. So if the exponents are the same, what does DC stand for on each DC? If the exponents are the same, here it is right here. Exponents are the same, y equals divide coefficients. What's the coefficient here? 1, 2. So it's 1/2. Y equals 1/2. That's according to rule each DC. Okay. Again, that's what that's referring to is it'll help you out if you're writing your limits for your end behavior. It's going to approach 1/2 both to the left and the right. And finally, let's do our intercepts. The y-intercept is found. The y-intercept is found by plugging 0 in for all x's. So it'd be 0 squared minus 0 minus 12 over 2 times 0 squared minus 8. All of that cancels. That cancels. Negative 12 divided by negative 8. The negatives cancel. What number goes into both 12 and 8? 4. So 4 goes into 12 3 times, and 4 goes into 8 twice. You could also say this is going to be 3/2 like this. That'll be the coordinate point for the y-intercept. And finally, the x-intercept, the last thing. How do you find an x-intercept? Set the numerator equals 0. I'm going to take this factored form since I already have it. I'll make it easier. I take the factored form. So x minus 4 times x plus 3 equals 0. This will provide 2 x-intercepts. This intercept right here, since inside lies, will become x equals positive 4. And this one would be located at x equals negative 3. Those would be the x-intercepts, 4, 0 and negative 3, 0. All right, let's check this graph and see if it agrees with what we're saying. This looks like it has a horizontal asymptote at 1/2. I agree with this. That has a horizontal asymptote at y equals 1/2. We have 2 vertical asymptotes. X equals negative 2 and x equals 2. That's the vertical asymptotes shown there. We have 1 y-intercept. This y-intercept looks like 1.5, which is what we had, 1.5. That's 0, 3/2. And finally, we have two X-intercepts. This X-intercept is at -3. Let me put it as a coordinate point. -3, 0. 1, 2, 3. That's at -3. And this intercept, 1, 2, 3, 4. It is 4 to the right. So everything we did there is correct. The domain is all reals except for -2 and 2. Exactly what we had. So our math was correct. All right. You have one. I want you to try from here to find the vertical and horizontal asymptotes. And from there, it looks like you would have to get the X-intercept as well to have your solution, or Y-intercept to have your solution. So this time you do have to do steps 2, 3, and 4. 2, 3, and 4 will get your answer this time. All right, so now we get into when we're bigger on top. You'll get to see that a little bit more. I'm going to walk you through what happens here. For domain. Step 1, domain. I would set the denominator as not being equal to 0. What's my one step here? Subtract 3. And so we'll find out that x cannot equal -3. When you come to, that means all reals except for -3. When you come to step 2, the numerator, that is not rational. I just know off the top of my head. Are there factors of -8 that add up to 1? Because only factors of 8 are 1 and 8 and 2 and 4. Do they add up to 1? No. So that's not going to cancel. There's no rational factors. So since it doesn't cancel, it's a vertical asymptote. Vertical asymptote at x equals -3. Remember the symbols are exactly opposite there. Step 3. Is this bigger on top, bigger on bottom, or are the exponents the same? Bigger on top. Now, here's the deal. If it's bigger on top, you will have a oblique asymptote, which I already wrote once, or a slant asymptote. I'm just going to write oblique asymptote, since I have not written that very many times today. The oblique asymptote is technically found by actually dividing the equation out. On this one, it would be really simple to find. If we did synthetic, I'm dividing by -3. So what I would do is I take the -3, because that's what x equals in the denominator, and divide that into, I have 1x squared, 1x, and -8. So step 1 was to find out what x equals. And remember, step 2 is check for missing powers. I did not have any. 2, 1, 0. So now this comes down. What's 1 times -3? -3. This combines. And then you multiply 6. And we're left with the remainder of, by the way, you're always going to have a remainder. Otherwise, it would have canceled in step 2. But if it didn't cancel, you should always have a remainder there. So that's the remainder. That means if this was a square, this is 1x. That right there is your oblique asymptote. The oblique asymptote is y equals x minus 2. That's what this graph is going to approach. So if you look far left, far right, it'll look like this line as you zoom out. And I'll show you that in the calculator in a moment, or in the picture. Okay, finally, Y-intercepts. How do we find the Y-intercept? I lost my notes here. You plug in 0. So if I plug in 0, it's y equals 0 squared plus 0 minus 8. I know I'm showing a lot of extra work that you don't have to have. Plus 3. The zeros all cancel. -8 divided by 3. That does not reduce. And finally, how do you find the X-intercept? Set the numerator equal to 0. I'm going to use my quadratic formula calculator for this. I created one. If you go to the Desmos graphs, quadratic formula, because I know it's not rational. The reason I'm doing this is I know the numerator is not rational. My A is 1, my B is 1, my C is -8. So I'm going to make that a -8. They're irrational These two x-intercepts are irrational. Here's how you write the answer here. The x-intercept is, if you read this on the solutions, the answer is line 7, x equals -1/2 plus or minus the square root of 33 over 2. And that's just reading the instructions right there. So for this one, the x-intercepts, here they are. It would be x equals -1/2. I'm getting this all from the calculator number 7, plus or minus the square root of this number, which is 33, divided by this number, 2. Square root of 33 does not reduce. So that would be the value right there. Those are my x-intercepts. There's 2 of them, and they turn out to be those crazy decimals right there. And so here's our picture. Check this out. This horizontal, this line right here. Let's do a little algebra 1. What's the slope of a line that's going up 1 over 1? What's the slope of a line that goes up 1 over 1? 1. Notice how our slope is 1. This crosses the y-intercept. It looks like down 1 unit, but you can see it's actually counting by 2s. So it is hit at -2. That is the oblique asymptote right here. I'll call this the oblique asymptote. Oblique asymptote at y equals x minus 2. That was my vertical asymptote at -3. Again, they're counting by 2s in this picture. X equals -3. The domain was all reals except for -3, and it does have those 2 intercepts, those 2 weird intercepts, -3.372 and 2.372. That's where those cross there. And the y-intercept was a little bit easier, -8/3. I'll add that one. That right there is -8/3. So I've given you a lot. It's time for you to do this one. Again, you could be using graphs for all of these. Example 5. It says here, determine any vertical and horizontal asymptotes, holes, and intercepts. So again, we're going to do the same 5 things. Number 1. What was the first thing we've been finding each time? The domain. You set the denominator as not equal to 0. So x squared minus x minus 6 cannot equal 0. That is a trinomial. We need to factor it. What are factors of -6? This is A, B, and C. What are factors of -6 that add up to -1? There's going to be 2 and 3. Which one's positive? Which one's negative?
2 is negative, 3 is positive.
To get me a -1, 3 is negative. So when I split the A term here, I split my A term's power. This is going to become x plus 2 times x minus 3 cannot equal 0. So now we have our spots. What can x not equal in the front factor? Because of 0 product property, by the way. Cannot multiply and be 0 without one of the 2 factors being 0. What can x not equal right here? -2. And what can x not equal right here? 3. Those are my 2 breaks in the domain, so it's all reals except for those 2 values. Now on step 2, since we have 2 breaks, we know we'll have either 2 vertical asymptotes, 2 holes, or a combination. We finally get to see a hole. I'm going to factor the numerator real quickly to help us out. I have x squared minus 9. If I set that equal to 0, how would you solve this numerator? Plus 9. So x squared would equal 9. And then how do you get rid of the square? Which means you have plus or minus because it's brand new. Okay, so we have x equals plus or minus 3. Now that's ultimately the numerator. So these factors, there's no GCF. This comes from the factors x minus 3 times x plus 3. What I'm writing out now is another way of explaining h of x equation. This is factored form. The denominator we already factored as x plus 2 times x minus 3. Now, what do you notice when I write this equation in factored form we could do here?
You could cross out
X minus 3. That means that's a hole. We have a hole at x equals 3. Now, the plus 2 does not cancel, so that is a vertical asymptote. Now, there's one more thing you can do. The hole will be represented by 1 point. If you want to know what that point is, you plug it in to this equation right here to find the y. We know the x value is at 3. If you want to find the y, you plug it into the leftover part of the equation, which would be 3 plus 3 divided by 3 plus 2. All I did is I plugged in that x value there. So now let me do that whole one more time. This whole will occur at, what's 3 plus 3? 6. And what's 3 plus 2? At 6 over 5. That will be my whole. All right, finally, step 3 is this bigger on top, bigger on bottom, or the exponents the same?
Same.
Exponents are the same. If the exponents are the same, how do you find your y-intercept? You divide the coefficients. So it'll be the horizontal asymptote. It will be y equals, what's 1 divided by 1? 1, because this is exponents are the same. And last 2 steps. Since we have it in factored form, the last 2 steps will be much easier. Whoops, let me write 4. Step 4 is the y-intercept. The y-intercept, you plug 0 into the equation for all x's. 0 squared minus 9 over 0 squared minus 0 minus 6. Cross out all these zeros. What's a negative divided by negative is positive? What number goes into both 9 and 6? 3. 3 goes into 9 3 times. 3 goes into 6 twice. So we'll have a y-intercept at 0, 3 halves. And finally, the x-intercept. Now this one will be easier to solve. Sorry, this is the one that's easier to solve. Based off the numerator, you go off the canceled equation. Off the canceled equation, the numerator, if you set the numerator equal to 0, x plus 3 equals 0, what do you get there for your x? Minus 3. So at x equals -3 will be a 0. So -3, 0. Let's check out that picture. -3, 0, we do have a 0. We have a y-intercept at 3 halves. That's 1.5. No, this says it's counting by, it's not counting by 2s. That is a 2. That needs to be changed to a 4. That would be a -2. That's a -4. They messed up on the labeling because that should be at 1.5. This is that whole, which is 3, 6/5. So the y-axis isn't labeled right here. It should be counting by 1s, whereas the x-axis was also counting by 1s. This whole axis should be counted by 1s. So that's what they messed up on there. All right. We had a vertical axis, vertical asymptote at x equals -2. And a horizontal at y equals 1. Yep, that's all else is correct. All right, your turn to try dual number 5. All right, example 6. Let's apply this. It says here, water current. A tour boat travels 8 miles an hour in still water. Boat travels 12 miles with current from its dock to another dock and 12 miles back. If the rate of the current is c miles per hour, okay, the rate of the current here. Current is c miles per hour. I'm going to go ahead and mark that. So we have it. If the c is the current and a plus c is the boat's rate with the current, 8 minus c is the rate against the current. So if you add c, the current's with you if you're subtracting. So you're moving 8 miles an hour in standstill water, in other words. It says here the time t, so t is time, for the route is a function of the rate of the current, where t of c equals all this. It says graph and analyze, graph the function and describe and analyze the end behavior. So let's look at this graph. And I'll graph it just as given here, t of c, that means the time given the current will equal 12 divided by 8 plus c, and 12 divided by 8 minus c. And I need to zoom out a little bit. And so here's our graph given here, and I could take a picture of this and I'll import it over. And we can look at, so here is the picture of this graph, the function. So we've graphed it, and we're now going to analyze this. Let me put it over here in the corner. And that might be enough to, if I set this to the back. Okay, let me shrink it just a little bit more. That'll be good enough for us to see the graph. There it is. We could say for the end behavior, that goes off of the Y. Typically, it goes off the horizontal asymptotes, which looks like this graph approaches 0 as it goes left and right. So typically with end behavior, we say how far to the left, or what is happening to the Y as you go left. Is it rising, falling, getting flat? And you can see it's obviously getting flat and flat. And so the answer would be 0, except for this is real world. And remember, with real world, not everything is relevant. So real world, real world problem, not the whole domain is not always relevant. So we want to go off the relevant domain. So I want you to think about this. In this particular problem, T is the Y and C is the current, the X value. Can you have a negative current? Can a current move negative miles per hour? Answer is no. So I should actually erase part of this graph. It's impossible to have a negative current. So all this current from 0 over is bogus. Not only that, can I have a negative time? No, that would also be bogus. You can't have a negative time. So all this part of the answer is bogus. So really, you're going to find the end behavior off of this part of the graph. I'm going to go ahead and click this point, find out is it 0, 3. So I want to put the Y-intercept on there as 0, 3. Okay, so if I wanted to find my end behavior, I would typically ask how, and I was about to write f of x. This is going to be t of c. As, and here it is, c approaches. Normally we would write a negative infinity, but this graph doesn't go to negative infinity. That would not be realistic. It goes as left as far as 0. So as we approach 0, what is the y value? You would ask yourself, is it rising, falling, getting flat, or stopping? In this problem, it's stopping, and it's stopping at the y value 3. And then you need to do the same thing for the limit as t of c as, and normally we would say c goes to infinity, but c cannot go to infinity. It looks like this graph stops at wherever this vertical asymptote is. And I'll tell you that vertical asymptote is at 8 because it would make, if the current is faster than 8, the current's moving faster than the boat. So even though the boat is trying to travel, if it's moving slower than the water, it's going the wrong way and it'll never make up the distance. So this actually is going to approach 8, and that's as far as it can go. 8, and it's technically 8 from the left side. So we're approaching 8 from the left side. It goes up to, the time increases up to infinity. But as soon as the current hits 8 miles an hour, we can't make the journey, or we won't ever make it to the other dock. We'll actually get pushed the other direction. So that would be my end behavior. Now your problem, you can read it. It's going to be a little bit different, is that yours, you can solve using nsolve, trying to find out if, based off of 63 amps, of where that would go and solving from there. All right, let's take a look at example 7. So I'm going to use nsolve here to do the algebra. If you were going to do this by hand, what you would need to do is multiply by the denominator, which I can do in a second, but I'm going to go to nsolve here and first find the exact values to this answer. So first it says the first instruction is to graph the equation as given. So -7 divided by x minus 6, all that equals 0. Secondly, you need to graph each portion. So like the left side of the equal sign, y equals the left side of the equal sign, and y equals the right side of the equal sign. If you do that, anywhere the 3 graphs intersect, you have a solution. So I have a green graph, a red graph, and a purple. They intersect in 2 places. It looks like my answers will be -1 and 7. So that would be the answers to this particular problem. If you only wanted to use nsolve, that's how you could do it. Or by graphing, that's how you could come up with your values. If you wanted to do the algebra, what you would do is, like I was saying, is you just multiply by the denominator. Multiplying, you need to multiply everything and distribute. So every piece of this problem would get multiplied by x minus 6, the denominator. Which does a couple things. On the second term here, the denominator and the numerator would, cancel or simplify with one another, that would go away. And multiplying by 0 is always just 0. So really what I'm left with is x minus 6 times x, which, so if we distribute this, we'd have x times x, which is x squared. That's x times x. And I'd also have a negative 6 times x, which is negative 6x, and then minus the 7 equals 0. And from here, I have a quadratic setup. I have a, b, and c. And so I would just do I would do an x method to see if I have rational answers. So I'd be looking for factors of a times c, which is negative 7. That added up to b of negative 6. Now, normally I would do a t-chart. Well, I'll go ahead and write it out. But 7's really easy because 7's a prime number. The only thing that can multiply to be 7 is 1 and 7. So you just have to ask yourself, how do I get a negative 6 out of that? It would be 1 minus 7. 1 minus 7 would be your numbers. You would take your a term, you'd split it, split the power. Split the power. So instead of x squared, it become x. Then you take your plus 1, x plus 1, times x minus 7, and set that equal to 0. The zero product property states that if you are multiplying with the product of 0, the only way you can do so is that at least one of the factors equals 0. So you'd say you solve each factor individually is equal to 0. Over here on the left side, I would need to subtract 1. The opposite of adding 1 is subtracting 1. And we get our solution of negative 1. And over here, the opposite of subtracting 7 is to add it. And we get x equals positive 7. Notice those are exactly the answers that we had from InSolve. So we did do that correctly. So now I have one for you to try. You go ahead and try your luck. You can either use InSolve or algebra to see what you get for example 7. All right, number 8. So here we go, another problem we can use InSolve on. And what's nice about InSolve is this says there's going to be extraneous solutions. What that means is mathematically you could solve this and you're going to get an answer that's not realistic. It's not real. It doesn't actually work when you plug it back in. And so Desmos or a calculator won't ever give you the extraneous answers. It'll only give you the real ones. So I'll graph this and we'll find out what the real solution is. Forgot to do the division. There we go, division. X minus 1. I'm going to copy the left side. I'm going to highlight it, hold down Control, press C, and I'll paste it right there by holding down Control and pressing V. And I'll do the same for the right side of the equation, the right side of the equal sign. I'll hold down Control, press C to copy. Over here, I'll hold down Control, press V to paste. The answer is where the 3 graphs intersect. So I see here, it looks like 2 graphs are about to intersect, but there's no red graph, so that's not an answer. The only answer is going to be 2. X equals 2 should be our solution to this problem. And go ahead and paste this for later. We're going to have x equals 2 as a solution here. Now, if you're going to do the algebra, you would multiply by your denominator. So everything gets multiplied by x minus 1. And what that does is for our 2 fractions with x minus 1 as denominators, that simplifies. And so here, if I distribute, I'd have x times x, which is x squared. Negative 1 times x is negative x. Plus, we still have an x left over, equals 3x minus 2. Now I'm going to combine my like terms. These x's, a negative x and a positive x will cancel each other. But whenever you want to solve and your power is greater than 1, you need to get everything together and factor. So I'm going to subtract the 3x over, and I'm also going to add the 2 across. That way I can have a trinomial, and we can do X method factoring just like example 7. So now I have a trinomial, and we could do a trinomial factoring here. So I'm looking for, again, factors of a times c, which would be 1 times 2 is 2. That add up to b, negative 3. And again, I normally do a t-chart here, and I still will, but it'll be really easy because the only factors of 2 prime is 1 and 2. So you just have to think about, how do I get a negative 3 out of those? And the answer is both of them need to be negative. Negative 1 times negative 2. Those would multiply to be positive 2, but combined to be negative 3. take your a term, split the power. So it becomes x minus 1 times x minus 2 equals 0. And again, zero product property. The only way you can multiply with and have a product of 0 is that at least one of the factors has to equal 0. And so you solve each factor as being equal to 0. We could get this answer if x is positive 1, x equals positive 1. We could also get the answer if x is positive 2. But remember, on our picture, we only had one answer. We had the answer x equals 2. What happened with the 1? Why is it that this answer is extraneous when the algebra looks like that should be a good answer? How come the graph does not say it's a good answer? The answer is because you're not allowed to divide by 0. If you plugged in 1 minus 1 is 0, you'd be dividing by 0. And that's why it's extraneous there. You cannot divide by 0. So that would not be a good answer. So with that, you have this problem to try. You would have to multiply this, since you haven't seen this before, by not only x plus 2, but also x minus 5, which that is what that is right there. So you need to multiply all three by x plus 2 times x minus 5 if you're doing this by hand. X plus 2, x minus 5. This over here, x plus 2, and this x minus 5, which coincidentally those two will cancel here. X minus 5 will cancel there, and that will cancel there. And I'll let you do it on your own from that spot. Finally, let's take a look at these ACP problems. That says, which equation represents an asymptote for the graph of that function? Well, we could do this by graphing. We could also do it by hand. The algebra required is you would need to divide that. And since I don't know what x is, I would have to use long division, x squared minus x plus 5. And that would need to divide into the numerator, 3x cubed minus 5x squared plus 11x plus 1. And the reason I need to do this is because according to our rules for asymptotes, the vertical asymptotes, you said the denominator equals 0, but it would be x equals, not y. So if it's y equals, it follows the three rules. This is bigger on top. And so it's not horizontal, it's oblique or slanted. And so you would need to divide. And so you'd ask yourself the questions, if you remember, for long division. What is my leading term, 3x cubed divided by x squared? If you're not sure, 3x cubed looks like this. And you divide that by x squared. If you simplify here, you'd see that that is just 3x. So I need to divide by 3x, which eliminates A as an answer choice. And now I distribute this 3x squared, 3x through. So 3x times x squared gives me 3, and now x to the third power. I need to multiply 3x times negative x, which is negative 3x. There's two x's, so x squared. And I also need to multiply 3x times 5, so a positive 15x. And finally, step 3. Do not forget the fundamental rule of division. Switch all your signs. So those simplify. I have a negative 5x squared plus 3x squared. Negative 5 plus 3 would be negative 2x squared. And over here, it looks like a minus 4x plus 1. And now we need to do this one more time. What is this leading term? Negative 2x squared divided by x squared. So negative 2x times x divided by x times x. If you look over here, you'll notice it's negative 2. And we now have our answer. That's going to be the quotient, which is the asymptote. I don't even have to find the remainder. That's it right there. These numbers are out. It's 3x minus 2. How could you do this with a calculator? If you graphed it, f of x equals 3x cubed minus 5x squared plus 11x plus 1, all divided by x squared minus x plus 5. There's my graph here. And if I tried my asymptotes, say, okay, does that graph serve as an asymptote? No, that's not an asymptote at all. Would this graph serve as an asymptote? 3x minus 2. Ooh, that looks pretty good. You see how it's kind of cut through that graph pretty well. And I want to make sure I got everything typed in right first. 3x squared cubed. Okay, and then there's y equals 3x minus 5. Notice that is not as good as the green. Let me turn off the other options. So that is not as good as the green. And then finally, there's y equals 3x minus 8. And that's even worse than the purple. So out of these two, which one more aligns with the graph? The answer is the green equation. And so yes, that would be the correct. And if I zoomed out, you see these will start to look really similar. And so yeah, that is the answer here, 3x minus 2. And now the second problem, for which value of x does g of x have a removable discontinuity? Now this, remember, means that a factor cancels, or it's a whole. So you could graph and look for the hidden, that open circle on Desmos, which I'll go ahead and type it in and show you. A removable is not the infinite. So don't get confused thinking, let me type this in so we have the equation. I can see this is how you're going to have 2 breaks because the denominator has a second power. So it'll break twice. I don't want you to get confused thinking that this is the vertical asymptote or the infinite discontinuity. So when I look at this, it's not going to be this break. That's one of them. There should be a hole somewhere in this graph, and it won't naturally show you the hole. So you can either go to table to try to find it. You can highlight the graph and try to find wherever the graph flashes to a white circle, which is hard to do if you go as fast as I just did. You have to go a lot slower. Or you could go edit settings, table, and try to find it from there, adding values. But I'm going to do the algebra first. What I need to do is see what cancels. So I need to factor this. I want to factor the numerator first. So I'm looking for factors of a times c that add up to b, which that's negative 18 that add up to be negative 3. Factors of negative 18 that add up to 3. Let's do a little table here to help us out. There's 118. There's 2 times 9, 3 times 6. 4 doesn't go in. 5 to, okay, I think that's all of them. And so which one of these could give me a negative 3? Answer 6 and 3 and 6. I can make it 3 minus 6. So 3 minus 6. You take your a term and you split it. So I'm now going to split this a term. So it becomes 2x plus the 3 and 2x minus 6. And one of those two has to simplify. It's the back end. This one can be divided by 2. So we just discovered that the numerator, I'll go ahead and write it over here. The numerator is going to be 2x plus 3 times x minus 3. Okay, now let's do the denominator. We have a new a, b, and c. So a times c is negative 18 again. B this time is negative 7. Negative 7. I can use the same chart and look for a difference of 7. It's going to be 2 and 9. It'll be 2 minus 9. 2 minus 9. And these are for the same values all the way around. A times c. That's my b, m, and n there. Okay, now I would take these and I'm going to split the a term power. So instead of 3x squared, I'm going to have 3x plus 2 and 3x minus 9. Notice 3 can go into both of these terms. So when I simplify that, I'll have 3x plus 2 times x minus 3. That's my whole. I have 2 x minus 3s. What does x actually equal there? X equals positive 3. So now I'll go over to my graph and I'll confirm that x equals 3 as undefined. Let's just do 3. So you can see it skips it over here. And if I hit 3 exactly, it should be an open circle. There it is. So it is undefined.